Everyone, welcome back to my channel. In the last video, we have seen exercise 8.2 problems. Now, in this video, let us continue with 8.3 introduction and sums of 8.3. The topic is trigonometric ratios of complementary angles. Trigonometric ratios of complementary angles. Okay, so we know that when the sum of two angles is complementary, right? So here we are considering one angle as theta, the other one as 90 minus theta. So now let us consider a right angle triangle. This is 90 degrees. And if I consider a theta at this point, this will be 90 minus theta. Then we have sine 90 minus theta will be equals to cos theta. Cos 90 minus theta is equals to sine theta. Tan 90 minus theta is equals to cot theta. Cot 90 minus theta is equals to tan theta. Secant 90 minus theta is equals to cosecant theta. Cosecant 90 minus theta is equals to secant theta. So we will be using the 6 trigonometric complementary angles for solving problems. Now the exercise 8.3 first problem, that is sine 18 by cos 72 degrees. So either select a numerator or denominator and convert them in terms of cos. And if you are selecting the numerator, convert in terms of cos. If you are selecting the denominator, convert in terms of sine by using trigonometric complementary angles. So sine 90 minus theta can be written as cos theta. So I am writing sine 18 degrees as sine 90 minus 72 degrees. Okay. So this implies sine 90 minus 72 degrees by cos 72 degrees. This implies sine 90 minus theta, which will become cos theta. In the place of theta, we have 72 degrees by cos 72. Cos gets cancelled. The answer is 1. The second bit, that is tan 26 by cot 64. Okay, here also select either numerator or denominator, which you can write as tan 90 minus theta is equals to cot theta. So we are writing tan 26 degrees as tan 90 minus 64 degrees. 90 minus 64 is 26. This implies tan 90 minus 64 degrees by cot 64 degrees. This is tan 90 minus theta is nothing but cot theta, that is cot 64 by cot 64, both gets cancelled. Answer is 1. And the third problem, that is cos 48 degrees minus sine 42 degrees. So here also select either cos term or sine term. If you select cos 90 minus theta is equals to sine theta. So we are writing cos 90 minus 42 degrees, which is nothing but sine 42 it will become. Okay, so this is sine 42, right? Cos 48 has become sine 42 minus sine 42. Both gets cancelled. The answer is 0. Now the fourth problem, that is cosecant 31 degrees minus secant 59 degrees. Select any one. So cosecant theta can be written as cosecant 90 minus theta, we can write as secant theta. So I am replacing this 31 degrees with 90 minus 59 degrees, which will become secant 59 degrees. So secant 59 degrees minus secant 59 degrees, which will become 0. The second problem of this exercise 8.3, that is evaluate tan 48, tan 23 into tan 42 into tan 67 is equals to 1. We have to prove that this all product is equals to 1. So now I am selecting a pair whose sum is 90 degrees, right? So if I add 48 plus 42 will become 90 and 23 plus 67 will become 90, right? So out of these two I am changing any one in terms of complementary angle. Out of these two I am changing any one in terms of complementary angles. That is tan 90 minus theta is equals to cot theta. This is what I am going to use. So if I change the first one, I am writing it as tan 48 degrees can be written as 90 minus 42. If I subtract 90 minus 42, I will get back 48. And second term, tan 90 minus 67. 90 minus 67 will become 23. And rest as it is. Tan 42 and tan 67 is equals to 1. So now if you see here, tan 90 minus theta. Tan 90 minus theta is nothing but cot theta. So it will become cot 42 degrees. Here also cot 67 degrees. And these two as it is. Tan 42 degrees, tan 67 degrees is equals to 1. Now cot can be written as 1 by tan. Cot theta can be written as 1 by tan theta. So this implies 1 by tan 42 into 1 by tan 67 into tan 42 degrees and tan 67 degrees, which is equals to 1. So now this is in the denominator, this is in the numerator cancel, denominator, numerator cancel. So we are having 1 is equals to 1, therefore LHS is equals to RHS. Okay, now let us move on to the next problem, that is cos 38 degrees into cos 52 degrees minus sin 38 degrees into sin 52 degrees is equals to 0. So out of these two terms, select any one. Okay, if I change this, what I can write? Cos 90 minus theta, cos theta can be written as sin 90 minus theta. Yes, and here also let us select any one of the term. That also sin theta can be written as cos 90 minus theta. Okay, so now then this will become cos 38 can be written as cos 90 minus 52. Okay, into cos 52 minus this will become as sin 90 minus 52 again into sin 52, which is equals to 0. Now cos 90 minus theta is nothing but sin theta. Then this will become sin 52 degrees into cos 52 degrees minus sin 90 minus theta is nothing but cos 52 degrees into sin 52 degrees, which is equals to 0. So now I have sin 52 cos 52, sin 52 cos 52. In between minus, so both the terms gets cancelled. 0 is equals to 0. Therefore, LHS is equals to RHS. The third problem of the exercise, that is, if tan 2a is equals to cot a minus 18, where 2a is an acute angle, find the value of a. So here, the condition here is tan 2a is equals to cot a minus 18. Okay, and 2a is an acute angle. Then we have to find the value of a. So what we can write here, tan theta can be written as cot 90 minus theta. Okay, so I am replacing, this is in the form of, let us assume that this is in the form of theta. 2a is theta. Then I can write it as cot 90 minus theta, that is 2a, is equals to cot a minus 18. Both the sides cot gets cancelled. Then I have 90 minus 2a is equals to a minus 18. Shift a terms one side and constants other side. 90 plus 18 is equals to a plus 2a. 90 plus 18 will become 108 is equals to 3a. From that, 3a is equals to 108. A is equals to 108 by 3, that is 3 ones. 3 3 is 9. 3 6 18. So therefore, A is equals to 36 degrees. And if you check 2a, 2 into a, that is 2 into 36 is 72, which is an acute angle. Therefore, the value of A here is 36 degrees. The fourth problem, that is, if tan A is equals to cot B, then we have to prove that A plus B is equals to 90 degrees. So let us consider tan A is equals to cot B, right? Select any one, either tan or cot. So if you select tan, it is in the form of tan theta, which you can write as cot 90 minus theta. Okay. So but here in the place of theta, what do we have? A. Then it will become tan A can be written as cot 90 minus A, right? So I'm replacing completely tan with cot. That is cot 90 minus A is equals to cot B. Both the sides cot gets cancelled. 90 minus A is equals to B. Shift A. 90 is equals to A plus B. So therefore, hence proved. The fifth problem, that is secant 4A is equals to cosecant A minus 20 degrees, and where 4A is an acute angle, find the value of A. This is similar to the previous problem, that is first secant 4A is equals to cosecant A minus 20 degrees. Secant 4A, let us assume that as secant theta, which you can write as cosecant 90 minus theta. Okay, so it will become what? Cosecant 90 minus 4A is equals to cosecant A minus 20 degrees. Cosecant cancel. 90 minus 4A is equals to A minus 20 degrees. Okay, shift A terms to one side and numbers to other side. 90 plus 20 is equals to A plus 4A. So 110 is equals to 5A. From that, A will be equals to 110 by 5. That is 5 ones. 5 to 10, 5 to 10. So therefore, A is equals to 22 degrees. And check whether 4A is an acute or not. So that is 4 into A, which is 4 into 22 degrees, which is 88 degrees. So it is an acute angle. So from that, therefore, A can be what? 22 degrees. Now the very important problem of the exercise, that is, if A, B, C are interior angles of a triangle ABC, then show that sine of B plus C by 2 is equals to cos A by 2. So first, ABC is a triangle. Okay, in that they are interior angles. We know that sum of the interior angles of a triangle is 180 degrees. So A plus B plus C is equals to 180 degrees. Now, we'll follow this. According to this, we'll solve. We have on the left hand side B plus C values. So let us keep only B plus C values. Shift A value that side. So this will become B plus C is equals to 180 minus A. Okay. Now both the sides I have divided by 2. So let us divide by 2 on both the sides. Divide by 2 on both the sides. Then it will become B plus C by 2 is equals to 180 minus A by 2. So this is B plus C by 2 is equals to 180 by 2 minus A by 2. From that, B plus C by 2 is equals to 90 minus A by 2. Right? Now I have sine on the left hand side. So apply sine on both the sides. Apply sine on both the sides. Then it will become sine of B plus C by 2 is equals to sine of 90 minus A by 2. So now, if you see the right hand side part, that is sine 90 minus theta we have. Sine 90 minus theta is nothing but what? Cos theta. Right? So then it will become sine of B plus C by 2 is equals to cos A by 2. This is what we have to prove. So therefore, hence proved. The last problem of the exercise, that is, express sine 67 degrees plus cos 75 in terms of trigonometric ratios between 0 and 45 degrees. So we have to express this sine and cos in between the angles 0 and 45. So for that, first let us consider sine 67 degrees plus cos 75 degrees. So now we are trying to express this in terms of 90 minus 67 can be written as 90 minus 23 degrees, and this cos can be written as cos 90 minus 15 degrees. Okay, 75 plus 15 is 90, 67 plus 23 is 90. So now this is in the form of sine 90 minus theta. Sine 90 minus theta is nothing but cos theta, and this is like cos 90 minus theta is equals to sin theta. So therefore it will become cos 23 degrees plus this will become sin 15 degrees. So we have expressed 67 and 75 in between 0 and 45 degrees.